So first thing we're going to talk about today, section 3.5, graphs of square roots and cube roots. We are now adding two more memorized graphs to your list of memorized graphs. So we've already got linear, we've already got x squared and x cubed, and absolute value of x. Those are the ones that you should already have memorized. So today we are going to add the square root graph and the cube root graph. So anytime you see the square root of something, you should know it automatically is going to look something like that. Anytime you see the cube root of something, or a fifth power of something, the fifth root, like the third root, fifth root, seventh root, any odd root, it's going to look something like that. Any even root is going to look something like that. Our even powers look like this one. Remember? X squared, x to the fourth, x to the sixth, x to the 200th. Our odd powers look like this one. This function is the inverse of this restricted function because this one fails the horizontal line test. This function is the inverse of this one because this one passes the horizontal line test. So, first thing I'm going to write down is the generic graph terminology. If you have a graph of f of x, which is, if I give you a picture and say, hey, that's the graph of f of x, you can come up with a new graph. Using those kinds of transformations. And we've already covered this when we covered quadratics earlier this year, when we covered our cubics earlier this year. This number right here, the a, if a is greater than 0, it's right side up. Yes, that one's a k. This one's right side up. If a is 0, it's upside down. H comma k is a key point. I'm just going to write the word key point. What?
This looks exactly like...
Yes, it does look exactly like the stuff we were doing in vertex form. Because it means the exact same thing. In vertex form, what's the key point of a parabola? Vertex, right? Okay. What do you think the key point's going to be here?
0, 0.
It's where that graph starts.
Which is...
What do you think the key point is on this graph?
Right.
The graph starts at negative infinity, so no.
0, 0.
It's the middle point. It's called the inflection point. It's where it's going from concave down to concave up. That's that key point on that graph. Again, the inflection point, where this one's going from concave up to concave down. So a key point is found if this is in the transformation form. Okay? So all we're going to do is we're going to learn how to do graphs by transformations. This says take your parent graph, move it this amount in the opposite direction horizontally, move it that far up and down, and scale it. Okay? Fairly straightforward. So for quadratics, we went over 1, up 1, and then over 2, up 4 for our parent function, right? We put a 1 in and got a 1. We put a 2 in and got a 4. What we need to do is we need to find out what the key points are on the square root of x and the cube root of x graphs. So, what we are going to do is we're going to put in easy points that we're able to take the square root of. What numbers am I allowed to put in the square root function?
All real and positive numbers.
Can I put 0 in there?
No. All real numbers?
Wait,
all real non-negative numbers.
Non-negative numbers. So can I put 0 in there?
Yes.
Yes. Because what's the square root of 0?
0.
What's the next number that you can take a perfect square of?
4.
1. What is the square root of 1? So that's my second point on here. What is the next easiest number to take a square root of? 4. And what's the square root of 4?
2.
Those are the 3 points that you need to graph a square root function. You are going to put numbers in so that you're able to find easy square roots. And I'm going to do examples of it with shifts. Don't worry about it. Don't worry about it. I don't worry about it. So I'm going to put easy numbers in so it's easy to find shifts. Cube roots. Where's my inflection point normally?
Towards the origin.
It's not towards the origin, it is the origin, which is what x coordinate? 0. So that's the same thing as writing the cube root of x, x to the 1/3. What is the next number that I can take a perfect cube root of?
1.
1. What's the cube root of 1?
1.
What is the next number I can take the perfect cube of really easily? 8. So what you want to think about, what we're thinking about here is, what is 1 cubed? 1. What is 2 cubed? 8. Those are the 3 points on that arm. You need 3 points on the other arm, which would be -1, -1, and then -2, -8, -2.
So you're basically just mirroring it after you find those other points.
Yeah. Anytime you can use symmetry, you use symmetry to graph a function. Okay? So you need 3 points on each arm, with one of the points being in common. So for the cube root, you need 5 points total. For the square root, you need 3 points total. That is on your final graph. First thing we're going to do is we're going to use transformations to come up with the cheat sheet for our final graph. Okay? So I'm going to work through some transformations and then show you how we come up with our final graph. On your test, it'll say graph the following using sketch the graph of the following using transformations, then provide me a final graph. And the directions on a test are going to say your final graphs must be no smaller than a half sheet of paper. So don't go by ones on your final graph. Because remember, what do you do if you give me an itty-bitty graph? Itty-bitty grade. You have half a sheet of paper, so you're going to scale it out. So you use a full sheet of paper, half a sheet of paper on your final graphs for tests. So please, on 201, we are going to start with problem number 16. Can somebody read 16 to me?
F of x equals 2 roots x minus 1 plus 3.
Okay. What kind of graph is this? Is this the teapot or walk like an Egyptian? Teapot. So here is the way I want you to show me what's happening using transformations. First thing that's going to happen is I'm doing the square root, which is a teapot. That is the graph of the square root of x. Do you agree with that?
Mm-hmm.
Then what's the first, if I were to plug a number in for x, what's the first thing you're going to do to that number right now? If I plug a number in for x, like a 5,
Subtract 1.
Subtract 1. What does the subtracting 1 going to do to my graph?
Bring it down 1.
No, it's not going to bring it down 1.
I have a question.
Inside a function moves it left or right. It moves it horizontally in the opposite direction. What, Cross?
If that's subtracting 1, what if you put in 0?
Opposite direction.
I said the opposite direction, and 0 would not be allowed in this one.
Okay, that's what I thought.
So this is at -1. Oh, opposite direction. I need to move it 1 to the right. I just mentioned that, and then I drew it the wrong way.
Yeah, that's true.
So that is that part of the graph. What is a positive 2 going to do to my graph?
That's yeah.
Okay, what happens to a linear, what's the slope of a, this is a slope of 1, right? What's the slope of 2 going to do to this line?
It's going to make the incline more.
Twice.
It's going to make it, starts with the letter S. Steeper. What do you think that 2 is going to do to my graph?
Make it
Starts with the letter S.
steeper.
Okay. If this number is more than 1, it makes it steeper. So it starts out like a teapot. then it's going to be a steeper teapot. Okay? So my next graph would be 2 times the square root of x minus 1. And all you're going to do is, instead of kind of drawing it like this, you're just going to make it shoot up faster. Okay? And my last transformation. What do you think that plus 3 is going to do to my graph?
Bring it up 3.
There you go. I'm going to move it up 3, and it's going to shoot up steep. That is your answer key for your graph. On a test, if I just ask you to sketch the graph using transformations, you are done at this point. If I ask you to graph using the instructions followed in class, that's the first part of your work. That's your answer key. Now, if we were going to make a full-blown graph, what we are going to do now is we now know what numbers to start sticking into my graph. The numbers I want to stick into my graph are, so when I take the square root, I'm taking the square root of 0, 1, and 2. 0, 1, and 4. What number do I have to put in here for x to get a 0?
1.
A 1. If I put a 1 in, what's 1 minus 1?
0.
Square root of 0. 0 times 2?
0.
Plus 3?
3.
Does that agree with my sketch graph?
Yes.
Okay. The next point I want to put in here is what's going to give me a 1 underneath the square root. What number do I have to put in here to make this a 1?
2.
A 2. 2 minus 1.
1.
Square root of 1 times 2 plus 3.
5.
5.
Next number I want to put in here is what's going to make this a 4. So I put a 5 in. 5 minus 1.
4.
Square root of 4
2.
times 2
4.
plus 5
7.
Plus 3.
plus 3 is
7 still.
It's
Plus
7.
7.
7. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5. And then we're going to use a nice smooth curve. And then you're going to show me that that continues up forever. Any questions on how to come up with the final graph after you show me what you're doing using transformations? Final step, does it agree with your scratch graphs? Does it agree? Wouldn't it be nice if you could always have the answer key to your test questions? Because that's what you're doing, is you're creating your own answer key. The reason why I have you do these scratch graphs is because every one of these functions that's on the board above my head, every single one of them, I can write in this form and do the exact same transformations with them. Okay? Every single graph that's up there, I can do these exact same transformations. That's not in your textbook. But that's the easy way to interpret what is happening to the graph of a function. Yes, David? I see there's something in the head.
So in the next one, it would be 7, 9?
No, the next one is what's going to make this a 9,
Be 10.
which would be a 10. Because the next perfect square I can take is a 9, right? I want to put what's underneath the radical has to be a 9. So I'd have to put a 10 in for x. And that square root of 9 is 3. 3 times 2 is 6. 6 plus 3 is
I
9.
thought we were going with the slope, which was 2, which every other one did.
Yeah, we're going every other number instead of, you just have to think, what can I take perfect cube roots of? What can I take perfect fourth roots of? What can I take perfect, square roots of? That's what you want underneath the radical, because you want the math to be easy for you. Okay? Want to do another one? Sure we do. We are going to do problem number, so I just did 16. Let's do number 20.
Stupid cube roots.
cube roots are fun.
No,
Because that's walk like the Egyptian.
you gonna walk like the Egyptian?
So, 20, what letter did they give us? Another F?
That's in grouping.
So they gave us a Y. Y equals -2 times the cube root of x plus 5 plus 5.
Yep.
Okay. I am not going to spend all the time I did last time on these scratch graphs. I'm going to show you how I would go about doing the scratch graphs on a test.
You're on a +5.
So, first thing I'm going to do is make this scratch graph of a cube root function. To walk like the Egyptian. I just know it's that graph. Next thing I'm going to do is shift it 5 to the left. And I'm going to draw that graph again. Then I'm going to flip it upside down and stretch it. 1, 2, 3, 4, 5. Flipped upside down and stretched. Then I'm going to take this whole thing and move it up 5. And it's still going to have that downward sweep and this upward sweep. Those are my scratch graphs. Any questions on those? Now I need to come up with my actual graph. The numbers I need to have underneath this cube root are 0, 1, and 8 when I get all done. I need to have a 0, a 1, and an 8, because those are the ones I can take perfect cube roots of. What number do I have to put in for x to get a 0?
-5.
-5. What's the cube root of 0?
0.
Times -2.
0.
Plus 5?
5.
Does that agree with my scratch graph?
Yes.
It's amazing how that happens. What number do I have to put in here to have a 1?
-4.
-4. -4 plus 5 is 1. Cube root of 1
1.
times -2.
2. -2.
-2 plus 5?
3.
3. So I'm going to do -4, comma 3. What number do I have to put in here to have an 8?
3.
3. 3 plus 5 is 8. Cube root of 8 is?
2.
2 times -2.
-4.
-4 plus 5.
1.
So 3, 1.
Would the next one be 16 after 8?
No, it would be 27. Perfect cubes. My perfect cubes are 1, 8, 27, 64, 125. 3 cubed is 27. 2 cubed is 8.
4 cubed.
4 cubed is 64. 5 cubed is 125. Now let's go the other direction. You can use symmetry if you want to, but I know I want to have a -1 in here. What number do I put in here to get a -1?
-6.
-6. Cube root of -1 is -1. -1 times -2 is a +2. 2 plus 5 is 7. So -6, comma 7. Next number I want to have in there is a -8. What number goes in here to make this a -8?
15. No.
13. -13. Cube root of -8 is -2. -2 times -2 is a +4. 4 plus 5 is 9. 8, 9. 7, 8, 9, 10, 11, 12, 13. And then we connect our dots with the smooth curve. And we put our arrowheads on the end. Cool? Any questions on how we use it? We get our answer key. Does it kind of match my answer key? Okay. The key point on my answer key is where is that key point, which is the inflection point. Okay. If I ask for just sketch the graph, you're done here. If I ask you to graph it on a test, once you do these sketches, you put in numbers and give me the actual number of points on the arms. Yes.
What about in the homework when it says graph the function?
I just want you to, these will be fine for me.
Okay.
Scratch graphs are fine if it tells you to graph it right now. Okay, maybe pick one or two of them to actually physically graph so you can kind of see how am I going to have to do my scale to make it fit on a half piece of paper. Because again, on this one, you still wouldn't want to go by ones. Okay, you want it to fit on a half piece of paper so it looks nice and big and pretty. Okay, so the rest of the problems in there are all square roots and cube roots. Please turn your page to numbers 28 to 33 on 202. If you know where a square root function starts, I'm going to call the coordinates of this point h comma k. Because isn't that what it is in my function form? I want to know the domain of this function. And then I also want to know the range of this function. The domain are what are my values of x I can put into this equation and get a valid result. What is the smallest x I could put in here and get my graph?
1.
Right here, 1. Isn't that a 1?
Mm-hmm.
That is the actual h coordinate. Can I actually put the h in? Is it going to be a solid? Is that a solid dot or a hollow dot?
Solid.
Solid. So my domain is from h to infinity. What is the range of this graph? The range are my y values. This y value is my k value. Do I actually touch that y value? Yes. This is assuming your graph is right side up. Okay? If your graph is upside down, you got to kind of look at it. It would be from negative infinity up to k. But if a is positive, that's what it's going to look like. Now I will tell you what the domain and range of every single cube root function is. It's the same. All real numbers. I can put any number I want to into an odd root. Okay? I can put any number I want to into an odd root. So if I give you a square root equation, you should be able to look at it immediately and tell me what the domain and range is. So let's look at problem number 29 and no, let's look at 31 and 33. 31 is y equals 1/3 the cube root of what?
1
X plus 7.
Okay?
Negative
And then the next one is?
F of x equals 1/4.
1/2.
No, I'm doing the next odd one.
31.
The next odd one.
Oh, it's 1/2? Yeah. So
1/4.
So this is 1/2. The next one is 1/4.
Yeah.
Square root of?
X minus 3 plus 6.
What is the domain and range of every single odd rooted function?
All real numbers.
All real numbers, all real numbers. So those questions are saying, without graphing, without doing any math, tell me what the domain and range are. Domain, negative infinity to infinity. Range, negative infinity to infinity. The domain and range of this one, the domain is from the opposite of this to infinity, because this is positive. The domain is
3 to infinity.
3 to infinity.
And then 6 to infinity.
The range, because this is right side up, is
6 to infinity.
6 to infinity. By looking at them, you should be able to come up with the domain and range. Yes, David.
I don't know why that's getting me. If that's that, then why is I wasn't
What?
listening for the top one? Why is that negative to positive then?
Look at that graph. What's the smallest x value for that graph? Negative infinity. What's the biggest x value for this graph?
Yeah.
Positive infinity. Same thing with the range. That's the top graph. It's a cube root graph.
And the bottom one is.
The bottom one is a square root graph. That's a teapot. The teapot has a starting point. Teapot has a starting point. It normally starts out at 0, 0. But this teapot is shifted 3 to the right and 6 up. So I have to shift my 0, 0, 3 to the right, and 6 up. Any other questions on domain, range, and graphs?